I hope so. Not sure. All right, welcome back. Good morning. Hopefully you guys are doing well, staying safe, ready for the best class of the day. Happy Earth Day. Earth Day today. Beautiful day. Snow this morning. It was a whiteout. Now it's like, where's the snow? It's gone. So we have full roster here. No need to take attendance. All set. Good to go. Couple things to note before we begin today's class. So a couple things going on. A lot of you guys are in 10th grade, 11th grade, whatever it is. And you guys have the ability to come back to school if you want to, starting in May. So you have the ability starting May 3rd, Monday, May 3rd, to come back if you want to. And it's going to be very similar to the routine that I already outlined with the juniors and seniors. So if you want to come back, you have to wear a mask, social distance, all that stuff. You'll eat lunch in the lunchroom. You'll be hanging out at a table, maybe with 4 people at the max. But the halls right now, just so you guys know, are pretty clear. So it's not too crowded in Proctor with juniors and seniors. Right now in classroom, I only have 2 people. So there's definitely room for some of you guys if you want to come back. It's your call what you want to do. I'm not telling you to come back. It's not a bad idea to start the routine, to come back to get some normalcy back into your life. Get out of the house a little bit. You've been in the house for a whole year. It's not a bad idea to start to get a routine, a different routine going. For one whole year, our normal routine was just getting out of bed, logging onto the computer, Zoom. That's your class. Now, hopefully, we're transitioning to switch it up to a different routine. Another announcement, if you're a junior, there's a announcement on Google Classroom. Not on my page, but your junior class page. I don't know much about the details regarding prom. And I believe that's a survey on there. So please fill out that survey. I don't know what the details, but it's regarding prom. Please check that out if you want to. All right. Anybody have any questions for me on the routine of rollback for 10th grade? So hopefully you guys are back into sports, your drama, athletics, whatever it may be. Things are starting to roll back open. All right. Let's check out the COVID report for today. So COVID report for today, let's see what's happening. Maybe this is how you're going to determine whether or not you're going to return back to Proctor. Maybe you're going to check it out, but you still have the option to go virtual regardless from now to the end of the year. I have no idea what's going to happen next year for school. Somebody asked what's going to happen next year with school. Do you think we'll be back? I don't know. We as a community determine this. Yeah, I think we'll definitely be in person at some capacity. I don't think we'll be virtual again, 100%. So I think we'll have the ability to be in person at some level. I don't know. We'll see what happens over the summer, all that stuff. Right now in the county, there's 444 active cases of COVID in the county. Resolved cases, there's 20,362 resolved cases. Deaths have been steady at 414. Hospitalization numbers have increased a little bit. 25 people in the hospital, 2 people in ICU. Vaccine numbers are increasing quickly. Not quick enough. If you want to get vaccinated and you're above 16, you have the ability to get vaccinated. You can check out the United County website for information regarding where to get vaccinated. The daily numbers of COVID in the county. Check it out. Nothing too crazy. Still a little inconsistent. There's 36 more cases of COVID in the county. All right, so there's the chart. Today's Earth Day. Before I get to Earth Day, reminder, COVID's definitely in the community. Be smart, be safe, protect yourself, protect your loved ones. So it is Earth Day today, and for Earth Day, I was watching the news this morning, and I saw this on the news. So protect the Earth, maybe not for yourself. Maybe you don't care about it, but maybe your kids eventually, or your kids' kids will have to worry about maybe water. Maybe you came from a different country. Maybe your family came from a different country and you had to worry about where are you going to get the water from. Water is one of the things we take for granted. You put the tap on, it comes right out. You go to the store, you put the water, you buy the water in the bottle, cheap. But some countries really have to work or travel for this clean water so they could drink it, so they could use it, so they could cook with it. so they could clean with it. One of these challenges for Earth Day is always water. Here we go. I'm going to start off with this video. I like this video because it's talking about the effects of water and the challenges that water is bringing. Here we go. Enjoy this one.
In Los Angeles, engineers and scientists are working to prevent the city from literally water. This as the Southwest continues to feel the effects of a mega drought. NBC News correspondent Jacob Soboroff has rare access inside LA's plan to combat its water challenges.
Just straight up, and straight back, and straight forward. Just like that. There you go.
Okay. Angler Lino Jubilato's been fly fishing here for over 30 years.
You're a natural. It's just so natural.
Your line in the Los Angeles River makes you almost forget where you are. A former concrete drainage ditch next to an interstate.
The 5 freeway. You can hear it.
Yeah.
You know,
it sounds like the rushing river, actually. While it doesn't often rush, the river's restoration was made possible by clean water from a local source.
There hasn't been any rain, so basically all this water that's coming in right now from treatment plants.
That's where it's coming from.
It's all from the treatment plants.
As in wastewater treatment plants. Toilet water.
You're lucky this is not smell-o-vision.
Michael Ruiz runs LA's Tillman Water Reclamation Plant, one of the main sources of LA river water.
So, Mike, what is it exactly?
In a scientific term, it's called mixed liquor suspended solids.
Mixed liquor suspended solids.
Yes.
Sounds pretty gross, but Mike and the city are able to treat all this sewage so it's clean enough to release into the river. But most of it doesn't end up there or anywhere for people to enjoy. Dolphins, on the other hand?
We're on our way out 5 miles into the Pacific Ocean to see where the city of Los Angeles is currently discharging hundreds of millions of gallons of treated wastewater every single day. Whoa!
These LA City scientists want to change that, and they're part of an ambitious plan to recycle all of LA's wastewater by 2035.
Given climate change, this is a pretty critical infrastructure project.
Yeah. Absolutely. So we're wasting less when it can be reused for other things.
Those other things include turning the treated wastewater being discharged from this pipe on the ocean floor into drinking water. LA Mayor Eric Garcetti couldn't be more confident in his city's plan to protect LA's water supply from climate change.
There it is, the smell.
By going toilet to tap, or showers to flowers, as he likes to call it.
Yesterday, we went 5 miles directly out that way to where this facility is pumping 250 million gallons of wastewater, treated, every day out into the Pacific.
We think by 2035, we can take about 216 million of those 250 million gallons. Instead of piping it that way, we'll be piping it back this way.
But first, he'll have to convince any squeamish LA residents.
Just want to be super clear that by 2035, the 4 million residents of the city hopefully will be drinking this stuff that started hours ago in our homes and showers and toilets.
Absolutely. You'll have the sweetest, cleanest, clearest water, and it's going to be right here from LA.
Garcetti's 2035 plan is already in motion at a different LA treatment plant called Terminal Island, where they use advanced technology.
You see all these?
Fernando Gonzalez, the plant manager there, offered me a taste.
This is the water that started how many hours ago as somebody's toilet water?
About a day.
About a day ago.
The entire process about a day.
So about a day ago, what I flushed down my toilet has ended up with this.
Yeah. Little sip.
That is delicious. That is good.
When teenager Greta Thunberg started skipping.
So there you go. One little situation where we're helping protect the earth or conserve, reuse things. Is taking our toilet water or shower water and transferring it over to drinking water. It is a huge problem that a lot of people in the world are facing. Something that we don't think about, but it's definitely a problem that other countries are thinking about or have to explore. All right, so happy Earth Day. Here we go. Let's figure out what's happening for the best class of the day. Welcome on back. Today's quote comes from, the week's quote comes from an unknown source. Good things come to those who wait, but better things come from those who will work for it. So whatever you want in life, if you're willing to work, you'll have some great results. Today's Thursday, April 22nd, 2021. It is a day one. We are definitely going to wrap up Unit 8 oxidation and reduction today. We'll finish up topic 5, electrolytic cells. We'll watch a flick on electrolysis of water. Oh, electrolysis of water. We know a lot about water. It's kind of why I played that video. You guys know about the properties of water. We know H is positive, O is going to be negative for the charges. We know we will take a look at examples on electrolysis of water or electrolytic cells. We'll give you time to work on the exit path on topic 5, and then we'll jump into unit number 9, which is acid, bases, and salts. So there's not a lot left for the year. We have acid, bases, and salts, organic chemistry, and nuclear chemistry. We have 3 units left. I plan to have acid and bases last 2 weeks, and then we'll go on from there with organic chemistry. It's going to be about at least 2 weeks for that, maybe 3 for organic chemistry, and then maybe a week or 2 for nuclear chemistry. That's the plan for the rest of the year. You will have a post-test. The post-test is very similar to the pre-test. You will also have a final exam. I'm not sure if the final exam is going to be the 4th quarter material or the entire year's worth of material. All right, starting off, here we go. Let's actually start off with what we talked about last class. Let's review what we did last class. So last class, we went through an electrolytic cell. Here we go, drawing with Mr. Brown again. Electrolytic cell, what I did a demonstration last class. And in that demo, I started off with a beaker. I took the beaker, it was empty, and I made it into an electrolytic solution. So electrolytic solution is going to be an ionic compound dissolved in water. It's a saturated solution. So I added some salt, some CuSO4 to water. I mixed it up. That is my electrolytic solution. What else did I do? I took a battery. So I also took a battery. It was a 9-volt battery. And that 9-volt battery had 2 different electrodes there. I don't have silver for a feature, so we're going to use purple for electrode. On that 9-volt battery, there's 2 different electrodes, 2 different sizes. One was a positive electrode, one was a negative electrode. So it's a 9-volt battery. We have a positive terminal, we have a negative terminal. All right, positive and a negative. What did I do yesterday's class? I took a penny and I took a nickel. I guess I'll start off with a penny. So there's my penny, copper, penny. And I also took a nickel. Let's take a nickel. My colors are a little off point. There's only so many features that zoom annotate gives me. So there's my nickel and my penny. What I do next, I connected my electrodes to the battery. So I connected them to the battery. I took alligator clips and I connected my penny to the positive electrode. And I connected my nickel to my negative electrode. That right there is an electrolytic cell. There's electrolytes, there's 2 different electrodes, there's a battery. Electrolytic cell. Questions for you? Please respond in the chat. How do electrons flow? Please respond in the chat. How are electrons flowing here? In the electrolytic cell, how are electrons flowing? How do electrons flow? Again. Thank you. I know Jumi La knows this. In the wire, from anode to cathode. Someone else said through the wire from anode to cathode. Yes, they definitely flow through the wire from anode to cathode. Next question. What's the charge of an anode? What is the charge of an anode? What? Charge of the anode. Yeah. Anode in this situation is going to be a positive charge. You definitely know that cathode's going to have to be negative. Cathode's going to be a negative charge. Cool. Anode positive, cathode negative. Next question. What is the conversion of energy? What is the conversion of energy? What's the conversion of energy? What's the conversion of energy? So 3 out of 4. It is electrical to chemical. Electricity is used to make the chemicals react. Electrical to chemical energy. Spontaneous or non-spontaneous? Electrolytic cell, is it spontaneous or non-spontaneous? Throw in the chat. Spontaneous means it happens automatically. Non-spontaneous means it needs some energy in order to happen. This cell right here, electrolytic cell, is non-spontaneous. Cool. One more question. Why not? One more question here. What flows through the electrolytic solution? What flows through the electrolytic solution? What flows through the electrolytic solution? What flows through the electrolytes? No, electrons flow through the wire. Oh. Good. One answer, good. What flows through the electrolytic solution? Ions. Ions flow through the electrolytic solution. So you have electrolytic solution, you have electrolytic cell. Once you have that, the first thing I would do is figure out some phrases. You should definitely know the charges. You should know positive charge, negative charge. You should figure out which one's the anode and which one's the cathode. So in this situation, I have my negative charge already listed for me. And my negative charge is connected to the nickel. So I'm following my nickel, following the alligator clip. The alligator clip is connected to the nickel. The nickel is going to be a negative electrode. The positive electrode is referring to, positive electrode is going to have to be the penny. So positive electrode, follow that alligator clip, that's going to be positive. So again, the situation, figure out the charge, anode, cathode. You told me that earlier, the green font over here to the left. Anode is positive, cathode is negative. So here we go, let's label this a little bit. Once you have that, next thing I would do is label your diagram. So what do you do for labeling? I'm going to have my negative charge. My negative charge is going to be what you already told me is my cathode. Whoops, that should be negative, not a 1. You should understand that the cathode is going to be red, cat, match up your cathode. This is reduction at the cathode. You should also understand the phrase, Leo says grr. Match the phrases. Grr. What does that mean? Gain of electrons is reduction. You have that, you're going to do a similar comparison on the positive side of the terminal. So think of this process. Keep it in the same order. We have the positive terminal, positive electrode. That is going to be the anode. You have the phrase red cat and ox. What's that mean? That means the anode's a site of oxidation. You have Leo says grr, match up Leo. What's that mean? Loss of electrons is oxidation. You should be pretty close to this point of where you should be able to label this as well. So negative electrodes the cathode, positive electrodes the anode, and then you can figure out those phrases, those corny phrases that I talked about throughout the year, and match it all together. You know the flow of electrons. Last thing I'll do in this diagram is a flow of electrons. Electrons go from anode to cathode. You told me that. Anode's positive. They're going to flow through the alligator clip, the copper wire. They're flowing through that because they're losing electrons. They're going through the battery. After it transfers through the battery, it's going from anode to the cathode. So the cathode is the nickel. The nickel is gaining electrons, gaining of electrons. It says it right there. Since it's gaining electrons, the nickel is going to be mainly negative. If I'm taking a bunch of nickels and putting them on, those nickels are the electrons are negative. If I add more and more electrons, this nickel, as it gains them, it's going to be negative. The penny is losing electrons, therefore its charge is going to be positive. So what happens in electroplating? What happens in the copper plating? This nickel is negatively charged. It's going to attract some positive charges, which come from the nickel. So these positive charges migrate on over from the penny to nickel to copper plate the nickel. So that's what gave it the copper effect, the copper coating yesterday in class. Does anybody have any questions on this diagram? Any questions on what just happened there? So yesterday in class, I did the demonstration. We took some notes on it. Today, we're going to analyze some examples on it. Any questions? Let's go. All right. Please open up the examples for topic number 5 for electrolytic cells. We'll do those together. Once we're done doing those together, I'll give you time to work on the exit pass. So open up the examples. None of you did it. Cool. There's 7 questions that are on electrolytic cells. Maybe you want to use your notes. Maybe you don't want to. I'm going to open my notes just for reference. Again, your notes should be complete at this time. If you missed class yesterday, rewatch the video, watch the recorded video, and then you can fill them out. Your notes are due Saturday. It's a big chunk of the grade. I'm not scrolling through this whole section of notes again. Check out yesterday's class if you need to. I'm going through electrolytic cells. I'm going to just open that topic up, and we can refer to this for the examples. Electrolytic cells. All right, so that diagram, second to last page of notes, here we go. So again, I'll do the first couple examples together, and I'll have you guys help me out with some, and then by the end of this, you should be able to do the rest on your own, the exit pass. All right, question number 1 says, the diagram here shows the electrolysis of fused KCl. What occurs when the switch is closed? So the first thing I know is this is an electrolytic cell. It's topic number 5. It's not a voltaic cell because there's only one beaker or one cell, one chamber here. There's one little area with liquid in it. It also has a battery, so that is definitely an electrolytic cell. Once I figure out it's an electrolytic cell, I start to label. I think about the process. So my suggestion for you would be figure out what things are. You have a negative electrode. That negative electrode is connected to this PT electrode. So that copper wire is connected there. Therefore, this is going to be a negatively charged electrode. It's connected to the negative terminal. This is going to be a negative. The positive terminal, positive electrode, is connected to this one right here. This PT electrode is going to be positively charged. Maybe you want to mark this up a little bit further in detail. I will. So here we go. We have the negative electrode. The negative electrode in this situation is a cathode. The first time all year, anode and cathode switch charges. Why? Because you have a battery used here. So it's going to be negative. It's going to be a cathode. I think of the phrase red cat, reduction at the cathode. And I think of the phrase Leo says, grr. Match up those phrases. So I matched up my reduction with reduction, the cathode to the cathode. So you can see that correlation, hopefully. So gaining of electrons is reduction. If you mark up your chart, it's going to make it a lot easier to analyze and figure out what the correct answer is going to be. Do the same thing for the opposite side, the positive electrode. Think about the process. It's a positive charge. It's got to be an anode. It's going to be anox. What's anox mean? It means anode is a site of oxidation. It's going to have to be Leo. Good. And we know Leo is the loss of electrons is oxidation. If you mark up your chart, it makes it so much easier to figure out the answer. All right, so what occurs when the switch is closed? Positive ions migrate towards the anode. Let's see. Positive ions migrate towards the anode. There's a positive ion, K plus. It migrates towards the anode. Anode would be positive. So do they migrate positive to positive? No. Positive positives are not going to attract. It's like a magnet. You have to have opposite sides in order to attract. So if you have two north poles of a magnet, they're going to repel. They're going to bounce off each other. They're going to push towards each other. If you have a positive and negative, they're going to attract. A north pole, south pole, attract. Two like charges repel, opposites attract. So no, positive ions are not migrating towards the anode because anodes are positive. The positive ion has to migrate towards the negative. Opposites attract. Now you have to see what the answers are here below. You scroll on down for a second. A little off now. It says positive ions migrate towards the cathode, yes, where they lose electrons. So we know the positives are attracting towards the cathode. And if you look at your little section of notes here, it says positive ions migrate towards the cathode and they gain of electrons. They gain electrons there. So GER is a statement that would help you out here. So the best answer in this question, positive ions migrate towards the cathodes where they gain the electrons. Once you put the two phrases in there, it's so easy to solve for these answers. Positive ions migrate towards the cathode where they gain the electrons. So this situation, cathode is going to be negative. So it says a positive charge. Question says, it says a positive ion. Wants to know about the positive ion? It's going to go towards the cathode. Oh, wait. I really messed that one up, didn't I? Yeah, I messed that up, folks. I apologize. Thanks, Jumila. Positive ions go towards the negative charge. No, I didn't mess it up. Positive go towards the negative. Positive to negative. The negative is going to be the cathode. Best answer is going to be choice D here. Hopefully that phrase helps you out. Anode was positive. Anode is positive. Anode is definitely positive in the situation. This positive ion, that K, is going to attract towards the negative electrode. Right where my mouse is right now, the negative electrode is my cathode. It's going to attract towards the cathode. Choice D is the best answer for number 1. Does that help a little bit, or you still have questions? So mark up your diagram. Think about the process. Positive ion is going towards a negative electrode. Positive to negative. One best answer is going to be D. Let's try another one. Number 2, in electrolytic cell, the negative electrode is called what? Please put the answer in the chat. Use your notes if you need to. Electrolytic cell, the negative electrode is called what? Use your notes if you need to. Please put your answer in the chat. Okay, I have 26 people online right now. Please Respond with your answer in the chat. Best answer for number 2 is, yeah, if you know the charges, this is going to be really easy for you to do. Negative electrode is going to be the cathode. Cathode is going to be where reduction occurs. Choice D is definitely the best answer. Cathode's negative. It's going to be reduction occurs at the cathode. Red cat. Number 2, best answer is going to be choice D. So that green font in my notes would help me out quite a bit. Number 3, an electrolytic cell. A negative ion will migrate to and undergo oxidation at what? Take some time to think about it. I'll give you about 45 seconds to do so. Once you're done with that 45 seconds, please put your answer in the chat. Please do number 3. Okay, let's see how we did. Please record your answer in the chat. We're talking about negative ion will go towards, migrate to, and undergo oxidation at what? Please record your answer in the chat. All right, let's see. So here we go. First thing I think about, electrolytic cell. It's this cell right here. Negative ions will go towards and undergo oxidation at what? So I think of the phrase oxidation. I think of red cat and ox. Oh, oxidation's at the anode. So it's got to be the anode. And ox, anode, site of oxidation. Again, a negative ion will migrate to and undergo oxidation at what? So negative ion is going to track towards, think of oxidation, follow your oxidation. Anode. Anode. Anox gives you the answer. Anode, oxidation, okay. Which is going to be what charge? It's going to be positively charged. That positive charge right there, choice B is the best answer for number 3. 3 is B. Use the diagram, use your notes to help you out. Hopefully know the charge of an anode and cathode. Anode charge is positive. Choice B for number 3. Number 4, another one. Which statement best describes the key? We have a key in a electrolytic cell. There's a power source which acts as the battery. And we want to know some information about the key. Which statement best describes the key? Some key information. There's no terminals labeled up here, but if we follow the flow, there's a positive charge there. Therefore, this is going to be positive. This is going to be the negative terminal of the battery, leaving the key very negatively charged. A lot of negatives on that key. Try this one out. Please come up with the best answer. I'll give you 45 seconds to do so. Thank you. All right, so some of you guys have to figure this out. The charges for electrolytic cells, they flip-flop for anode and cathode. The negative charge is a cathode. The positive charge is the anode. So you have to know the charges flip-flop because you do have a battery. So negative charge is going to be the key. That's going to act as a cathode, and we know the charge is now going to be negative. There's a lot of negative electrons going from it. Electrons go from anode to cathode. The cathode gains a lot of electrons, is negatively charged. Best answer here, choice A. Acts as a cathode and is negative. A is the best answer for number 4. Number 5, question reads, in electrolytic cell, the anode is always what? Think of the two phrases. Give you 30 seconds on the clock. Please attempt it. Please try it out. See how we do. Please record your answer in the chat for number 5. Think of the phrase and red cat and an ox. Red cat and an ox. Please put your answer in the chat. It's asking about an anode. Talking about an ox. Anode, oxidation occurs. Oxidation, definitely not A. It's definitely not going to be C. Not A, not C. Anode's charge is positive. Anode's charge is positive. Electrolytic cell, anode, positive. That's better, Tristan. Good. D is the best answer for number 5. 5 is D. Thank you. A couple more, folks. Let's go. Number 6. Which statement best describes the redox reaction that occurs when an object is electroplated? Try this one out. 30 seconds on the clock. Give it a shot. What's the best answer? Please record your answer in the chat. We're talking about electroplated, electrolysis, electrolytic cell. Nice. Same answers rolling in. Good. Electrolytic cell, a cell that requires electricity to cause a non-spontaneous reaction to occur. It requires electrical current. It requires electricity. 6, the best answer is choice C. Nice job, guys. Last question. Here we go. The diagram below shows a key being plated. This question's on the exit pass too, just so you know. The diagram below shows a key being plated with copper in an electrolytic cell. Given the reduction reaction for this cell, reduction occurs at what? Think about it. Figure out the charge for positive, negative, mark it up, figure out those phrases, come up with an answer. 45 seconds on the clock. Give it a shot. Please record your answer in the chat. Okay, if you're still stuck, you should have been able to go through the process. You should be able to do the process of figuring out what the charge of the electrodes. The negative charge is going to be the cathode. With that, you should understand that it's going to be red, cat. With that, you should understand it's going to be gaining of electrons. You should be able to do it for the other electrode too. You should be able to figure out that the positive electrode is going to be the anode. You should understand it's going to be anodes instead of oxidation. You should be able to understand that LEO, you're losing electrons at the anode. Electrons flow from anode to cathode. All right, check out my answers. Only a few answers here. Please record your answer in the chat. Reduction occurs. Use those phrases. It helps you out so much. Reduction occurs. Should use different color. Reduction occurs. Reductions over here. Reduction. Where does reduction occur? It occurs at the negative electrode, or A. A is going to be your cathode. That's the last question, last answer for the example. So choice B is the best answer for question number 7. These examples, you can submit them. Hopefully you got a 7 out of 7. Does anybody have any questions on this before we move on forward? I'm not grading this. I grade the exit passes. Okay, hopefully you have a clear understanding on electrolytic cells. Please open up your exit pass on topic number 5. Let's do this. Open up the exit pass, topic number 5, electrolytic cells. There are 7 questions that will be graded on electrolytic cells. Follow the same protocol that we just went through, the same procedures that we just went through. It'll make it so much easier. So again, figure out electrolytic cells, figure out the charge. Hey, you saw that one before. Label them, you saw this one before too. And then submit your work as well. I am going to put you in breakout rooms by yourself. Please attempt it. Please go through this. This is going to be completed right now. If for some reason you do not finish it, it will be due on Saturday. Please join your breakout rooms. If you have questions, please ask for help. I'm here for you. I'm going to give you 15 minutes to go through this right now. So at 12:43, we'll break out of the breakout rooms and we'll switch to the next topic. Please join your breakout rooms. Complete the exit pass on topic number 5. If you have any questions, please ask for help. Please complete this assessment. Please join your breakout rooms. Please complete it. Hey guys, again, please join the breakout room. Please complete the exit pass. If you have any questions, ask for help. Ellen, Joey, Jordan, Kim, please join the breakout room. Please complete the exit pass. Thank you. Okay, 20 more seconds, everybody. We'll be back from the breakout room. We'll continue on to the last portion of class, acid and bases. All right, hopefully you finish up that exit pass on topic number 5, electrolytic cells. We are all done with unit number 8, redox reactions. So next, we're talking about a whole new unit, unit number 9, acid, bases, and salts. So acid, bases, and salts, we're gonna start off with topic number 1. My goal for the rest of today's class, there's not a ton of time, is to get some basic properties, basic ideas on what an acid is and what a base is. Yes, we talked about acid and bases in probably 8th grade science, probably before that, probably earth science, probably biology, and we're definitely going to explore that a lot more closer detail of what makes an acid and what makes a base a base. Oh, I forgot to play that video today. I don't think I played that video. Feel free to watch the electrolysis video if you'd like to. Moving on forward to acid and bases.
From the tangy bite of a piece of fruit to the caustic liquids used to clear a clogged sink, acids are a type of chemical that could be found in many different aspects of our daily lives. But what is it about acids that makes some safe to eat and others dangerous? When talking acids, we're going to be talking hydrogen. Not the gas, but rather the hydrogen ion H+. This is a hydrogen atom that has lost its one and only electron. All acids produce H+ ions when dissolved in water, but it's how much H+ a specific acid can produce in water, whether it can be safely eaten. But how do we conceptualize and measure H+ concentration? Søren Sørensen, a Danish chemist, pondered this question when he worked at the laboratories of a commercial brewery in Copenhagen. It was in 1909 that he developed a method of quantifying acidity, what is now known as the pH scale. His scale works by simply converting the concentration of hydrogen ions in a solution to a number between 0 and 14. If a chemical is acidic, then its pH will always be below a 7 on the scale. The lower the number, the higher the hydrogen ion concentration. The pH scale is a logarithmic one, meaning that 1 unit difference on the scale, say from 3 to 2, means a 10-fold difference in H+ concentration. But 0 to 7 is only half of the picture. So what about all these numbers above 7? Substances that correspond with this half of the scale are called bases, and they are the chemical opposites of acids. The 7 on the scale represents neutral pH, what would be perfectly pure water. Like acids, bases are found in chemicals that we encounter in our everyday lives. Cleaning products such as ammonia and baking soda are bases, as are some simple medicines like milk of magnesia. They're bitter to the taste and often slippery to the touch, kind of like soap. Even though bases are different than acids, they too can be strong or weak, and a strong base can be just as dangerous and corrosive as a strong acid. Chemically, the difference between acids and bases is that acids produce hydrogen ions and bases accept them. In water, acids produce H+ ions and bases produce OH- ions. In reactions between acids and bases, hydrogen ions will react with hydroxide ions to make water. This type of chemical reaction is called a neutralization reaction. Acids and bases are also very important in biochemistry. Many biological processes are sensitive to the pH of the surroundings, so controlling acidity in the body is crucial. Some biologically important molecules like amino acids have dual personalities. They're said to be amphoteric, which means that they can act as both acids and bases. An amino acid has a carboxylic acid group that can produce hydrogen ions and an amino group that can accept hydrogen ions. Acids and bases are all around us and can vary greatly in terms of their use and their nature, but they all involve hydrogen ions being passed around. Thanks for watching. If you would like to learn more chemistry basics, make sure to check out these other interesting videos in the series.
All right, so we know a lot about acids and bases already. You go shopping at Walmart, you go shopping at Aldi's, wherever you go shopping, Hannaford, there's gonna be acids and bases all over the store. Go to the produce, there's gonna be a lot of acids. Maybe oranges, lemons, limes, pineapple, acids. Go down the pasta aisle, the sauces, acids. Salad dressings, acids. Soda, acids. Go down the cleaning aisle. You're gonna run into a lot of bases. So acid bases are always in our diet. We consume acids, we consume some bases in our diet. We should be able to know what they are. So acid and bases, let's open up the guided notes. Please open up the guided notes for the unit. This is what drives our unit. So please open it up. If you guys come back to school on the 3rd and you want to use a hard copy, you're more than welcome to use a hard copy as well. But you'll have to submit what you have digitally before you turn in the hard copy too. So you'll need to turn in both if you want the hard copy as well. So I'm gonna make a copy just so I don't mess up my original template. Please title your notes with your name. And we'll get some basic properties for about, I don't know, 5-6 minutes of class, and then I'll call it quits. So here we go, acid and bases and salts. Within this unit, we're analyzing 5 different topics. We'll be going through the basic properties of acids and bases. We'll talk about Arrhenius theories. We'll talk about topic number 2, Bronsted-Lowry theory. We'll talk about topic 3, Lewis dot diagram, Lewis theory. Topic 4, we'll go through the pH scale and pH indicators. And then topic 5, we'll go through neutralization and titration. All this I plan to figure out and get through in about 2-week period. So here we go, picking off. Starting off, we're talking about acids. So acids, I'm going to generally highlight in a red font. I'll bold, I'll highlight, I'll cap lock. So here you go, acidic solutions, acidic compounds, acids. Acidic compounds give food its tart taste. Acidic compounds give food its tart and sour taste. Tart or sour taste. So a lot of candies, sweet tarts, Sour Patch Kids. They're going to have some acids in there that give it its sour taste. They're going to be acidic. Acetic acid, probably in those candies. Sour taste. Acids taste sour, and they're going to change the pH indicator, change the color of an acid-base indicator. Acids taste sour, and they're going to change the color of an acid-base indicator. It's a test to figure out if something's an acid or a base, and can be used, can be a strong or weak acid. So there's strong acids, there's weak acids. We'll talk about what makes something strong, what makes something weak. Can be strong or weak, basically depending on the concentration. In an aqueous solution. So if something's diluted, it's going to be more of a weak acid. If something's concentrated, has a lot of H plus in there, a lot of acid, then it's going to be a stronger acid. Nothing too crazy there. We're not going to ever taste any chemicals, so we're not going to be able to tell whether or not something's going to be sour in the chem lab. But when you're consuming something, you're eating something at home, something tastes sour, it's probably going to have acid. It's probably going to be an acid. Bases have properties that you're probably not as familiar with. Basic solutions or bases. They're going to be bitter taste, more bitter. Bases have a bitter taste. And when I highlight my bases, I'm going to make them blue. There's a reason why I pick red and blue. You'll see it when we get to indicators. Bases have a bitter taste. Probably not in our diet much. A lot of bases are cleaning agents, cleaning supplies. But tasting most bases is going to be hazardous. You don't want to taste any bases or chemicals in the lab. So again, I know you're not here in class to analyze chemicals. When you take chemistry and maybe AP chemistry or college chem, you're never to try or taste or eat the chemicals. Yeah, that's a little dark. Might be tough to see. Yeah, I'll definitely change that to a lighter blue. That's cool. Thanks, Mike. Hopefully that's easier to see. Most common base that you're probably familiar with, you probably use it every day. Hopefully use it every day. Soap. Soap's a familiar base. The properties of soap, the texture, the physical characteristics of soap are something that you know of that you could make a connection with for a base. Soap, you feel it. As you touch a soap, it's going to feel very slippery. So soap has properties of a base. Soap is a familiar material that has a property of a base. Think about soap. Take a shower tonight. You'll analyze soap a little bit different. The slippery texture, the feel of a soap is another characteristic of a base. So bases, if you were to touch a base, maybe it's hydroxide. Maybe it's just soap. If you ever made soap, you know you use sodium hydroxide. But the soap is going to feel slippery. Bases are going to have a slippery texture. Last thing that I'm going to go through today, for the notes at least, is this last bullet below. So basic properties of base: they taste bitter, they feel slippery, they change the color of a pH indicator when tested. Change color, acid-base indicator. And they can either be strong or weak. Strong or weak depending on the concentration. We'll talk about characteristics that make it strong or weak next class. So next class, we'll go through more information about acid bases. We'll talk about Arrhenius acid bases. We'll figure out what makes an acid and what makes a base a base. So again, those are just basic properties of acid and bases. A lot of this you probably already analyzed in a previous class. Starting off slow. All right, I have like 8 minutes left of class. Hopefully you have the notes all set. For the 8 minutes of class, what I'm going to do to wrap up class, I did forget to play a video today. I'm going to go back to my Google Classroom page. I'm going to play the video on electrolytic cells. The electrolysis. Did I play this video? Electrolysis of water? No, I meant to play this right after that film, which I forgot to. So again, this is a recap. It should have been to finalize basically electrolysis or electroplating. So after this, we'll call it quits. Enjoy this flick.
Electrolysis is electrical current flow through a liquid which causes chemical changes. Yes, you did hear that correctly. Current flowing through a liquid. Now, not all liquids can conduct. The liquid can be a molten ionic compound or an aqueous solution. In either case, it must be able to carry current. Let's take a common example, table salt. If you heat sodium chloride to over 801 degrees Celsius, it will melt. The liquid will contain free-flowing positive sodium ions and negative chloride ions. This simply means that sodium and chloride ions are free to move within the liquid sodium chloride. Positive ions are called cations. Negative ions are called anions. Now consider putting two electrical conductors into the liquid. Copper would be good as it has a higher melting point. Nothing happens to the ions at this point, but if we connect the two bits of copper to an electrical cell or power supply, then things start to get interesting. We do need to sidestep for a moment to look at electrical current in a metal. From our lesson Behaviour of Metallic Structures, we know that electrons in a metal aren't bound to particular atoms. They form a sea of electrons that can move easily if a potential difference or a voltage is applied across it. This could be from an electrical cell or a battery. The electrons will begin to drift towards the positive terminal of the battery, and this is what happens when current flows. Current is the movement of charge, in this case electrons. Now, let's go back to our molten sodium chloride. We've added our copper wires, let's call them electrodes, and now we'll connect these to an electrical cell. The electrons will start to flow in the wires, and this will cause one electrode to become positively charged and the other negatively charged. This has an immediate knock-on effect in the molten sodium chloride, which you'll remember is a mixture of sodium cations and chloride anions. Anything positively charged in the liquid, in this case the sodium ions, is going to be attracted to the negative electrode. And anything negatively charged, in this case the chloride ions, is going to be attracted to the positive electrode. This is because opposite electrical charges attract. When the ions meet the electrodes, electron exchange happens, and this triggers a chemical reaction. Solids can form, gases can be given off, and new solutions can be left behind. It all depends on the liquid and what material the electrodes are made from. There is more detail about this process in our lesson Interpreting Electrode Equations. There are special names for the electrodes, which are usually metal plates with a larger surface area than a piece of wire. The positive electrode is called the anode, it attracts anions, and the negative electrode is called the cations. Is effectively conducting. The difference is that the charge carriers in the liquid, in other words the charged particles that are moving, are ions. If a liquid has free moving ions and can conduct like this, it is called an electrolyte. Remember that electrolysis can also take place in ionic solutions as well as molten compounds. The more concentrated that solution, the greater the ion flow rate. Ion flow rate can also be increased by increasing the potential difference or voltage across the cell. We'll be studying several examples of electrolysis in more detail in other lessons. For the time being though, here is a summary of the key ideas about electrolysis. Electrolysis is the flow of electrical current in a conducting solution or molten liquid that causes chemical changes. The conducting liquid is called an electrolyte and has free moving ions. The conducting plates, bars or wires inserted into an electrolyte are called electrodes. Positive ions are called cations and are attracted to the cathode. Negative ions are called anions and are attracted to the anode. When current flows in an electrolyte, it is the ions that move and carry the electrical charge. When current flows in the electrodes and wires, it is the electrons that move and carry the electrical charge.
All right, guys, that's going to be it for today's class. We'll continue on with acids and bases next time. Have a good day. Hey, the sun's out. Go enjoy that day. We'll see you later. Stay safe, guys. Bye-bye. Please don't forget to do the X-Pass if you didn't finish it. And Adina, have a good day. We'll see you later, guys. Bye, Kim. Bye, Tristan. Bye, Nidal.